My name is Guido Goldoni. I'm University of Modena. I'm a physicist, but we will talk about physics later. First, a few words about the city and how and the university and how you can live in Modena and study in Modena. No. Okay. So here is where our place here is. You know more or less how Italy looks like. We are in the north of Italy. It's in the middle of a flat, but for example, from the clock tower of the city, you can see the mountains, you can walk there. The place is reasonably nice to live. And the university is actually one of the oldest universities in the world. It was founded in the 12th century. And it's, a good point about this university is that this region and the district itself is very lively from the economical point of view. So most of the economy is about agro-food. We are proud to produce some of the best foods in the world, but we also engineer and produce lots of famous firms. A large district in automotive, which includes Ferrari cars, Lamborghini, Maserati, and other firms. We have one of the two European districts on ceramics, which is also nowadays a high-tech industry. And we have industries which are involved in packaging of food, because that's also an important point, and is also a high-tech industry nowadays. We have a very large biomedical district near to Modena. Okay, so it's quite rich and lively economical district. The city itself is was founded by the Romans, and it has one of the UNESCO World Heritage Sites because of a Romanic architecture. And the university, I will spend a few words, is a generalistic university, so it covers many cultural areas from life science, humanities, and sciences. So the university itself is not in one place. It's actually distributed between two cities, which are Modena and Reggio Emilia. Both are medium-sized city. There's between 100 and 200,000 people. We have a large number of incoming foreign students, more than 800, mostly from Europe, but also Asia and Africa. And in total, we have about 27,000 students. And we encourage our students to take also international programs, so much so we have about 1,400 students enrolled in international mobility programs. We have 13 departments in all areas, which run in total 87 degree programs. We will be talking here about few of them in English. And between our students, we have a slight majority of female students in general. Now, this is the list of the departments. So as you see, they really covers basically all sectors. So health and life science departments, from medical sciences to basic biology. We have two departments of engineering which cover from electrical engineering, mechanical, civil, telecommunication engineering, environmental engineering. And we have a few departments in social sciences and humanities, we have two colleagues here in these departments, and we have science departments. I am from the Department of Physics, Informatics, and Mathematics. Of the 87 degrees, as I mentioned, there are a few which are completely English-taught programs. Some of them are master courses, and some of them are PhD courses. Okay, so today we will be talking about the physics and nanoscience PhD and Reggio Childhood Studies doctorate programs. Okay. This is the list of the English-taught master programs, and today we will be talking about this programming languages, LACOM, and the master's degree in physics, which is my task to talk today. So in the end, the idea is the university itself is growing in the international dimension. So it's a specific goal to enlarge the international dimension of the university as a whole. One of the tools to increase this international dimension is to stipulate agreements with other universities, which are intended to increase the collaboration both in student exchange and research exchange. And as you see from the numbers here, basically we are covering all the world with a number about nearly 200 framework agreements. Within Europe, of course, we take part in the Erasmus Plus project, and we have quite a large number of students taking part in the Erasmus mobility programs. And the degree I'm involved in, which is physics, basically half of the students take Erasmus mobility program. Okay, so we switch the file, and I move on to my task, which is introducing to you the master degree program in physics and the PhD program in physics and nanoscience. Now, the university life in Italy is divided in departments. So my departments include physicists, expert in computer science, and mathematicians. Okay, and we share the department, and we coordinate somehow also the didactical activity. So the life in the department is in these two buildings, and these everything happens there. And these two buildings are in a scientific campus, which also includes chemistry department, engineering department, life science department, the university hospital. Okay, so life is somehow easy because everything happens here, and of course it's not far from the city center, and it is also, of course, it's a campus, so it includes also facilities, sporting facilities, and housing, and what is needed to students. But physicists sit only in this building, and they run in total 3 university courses: the bachelor, the master, and the PhD school. The bachelor is reasonably large. We have 70 new entries a year now, and is slightly, well, it's increasing every year, with a gender balance about 70% of males and 30% of females. Now, the Master of Science is somehow smaller. We have 20 new entries per year. Again, this number is somehow increasing. And we have a PhD school with 6 to 8 new positions every year, In this case, they are covered by, with fellowships, fully covered with fellowships, so the number is, of course, limited. Before talking about the courses, I should spend a few words about the research activity, because how a master program works and how the PhD school works is, of course, related to the researches which are taking place into the department. So our activities are divided in 4 areas, mostly, but as this picture suggests, these 4 areas are actually strongly interconnected. So we cannot really kind of puzzle, we cannot really trace strong boundaries between the different areas of research. One is quantum science and technology. You may know that quantum technologies is one of the flagships of Europe. The European Parliament devoted 1 billion euros for the flagship. This means, in terms of science, many different things, from spintronics to solid-state device to very theoretical aspects of quantum theory and so on. We have another area in surface physics and characterization. Surface physics means quite often a material in interaction with some other material or object. This is very, very important in many respects. For example, when 2 materials are in contact, they have a friction, and studying friction is one of the most important technological goals nowadays, because you want to reduce the friction as much as possible in most cases. But this also, and this requires strong expertise in the characterization and simulation of the surfaces. We have a sector of biophysics, which is involved mostly in the thermodynamics and mechanics of cells, and also in molecule folding and misfolding. So how proteins fold themselves to work in the right way, or how they fold in the wrong way and do not work anymore. So this is single cell studies, which are very important. And I mean, this technique got the Nobel Prize, not in Modena, but the same technique got the Nobel Prize 2 years ago. And probably the largest part of the activity is high performance computing, simulation, to simulate materials and quantum nano devices. So here we really have a strong expertise, and probably half of the department is in computational solid-state physics, how we should call it. So it means studying materials, starting from single atoms to small molecules to large molecules, and possibly in a multi-scale, so-called multi-scale approach. So this is just an overview of what's happening in research, and that, of course, drives what happens when students enroll in our master in physics. Okay, so these 4 guys are some of our latest degrees. The degree itself is divided in 3 curricula. Okay, so when you enroll, you have a bachelor in physics or some related area. You enroll in our master, you have to choose between one of the 3 curricula: in theoretical and computational physics, experimental nanobiophysics, or applied physics. I will go deeper in that in a moment. But before, what is common between all 3 curricula is the way it works. Students normally have to take about 13 exams to complete the program. The study plans within each curriculum are very, very flexible, so they can be personalized to the students' interest. However, we take care that some multidisciplinary aspect is preserved. So you want to study theoretical physics, that's fine. You will be a good theoretical physicist, but you should know some experimental physics, because you should be able to talk to experimentalists and vice versa. In our system, we have semesters, so there is a period of lectures from October to December, and another from March to June. Except from these periods, you can take the exams at any time you want. You can repeat the exams and so on. And toward the fourth semester, basically, you take the internship. That means you spend one or between 1 and 2 semesters in a research project. Okay, suppose you are a student, you want to study theoretical or computational physics. Then these are the exams that you may want to take. The first 2 are compulsory: advanced quantum mechanics, quantum field theory. Then there are exams which are strongly suggested to the student. These green ones are in color to emphasize that these are laboratory courses. They are theoretical computational methods you learn about, and you really experience them in a lab. Okay. Then you may want to choose different paths. For example, you want to study fundamental interactions or quantum gravity. So you take courses in elementary particles, gauge theories, and so on. Okay. Or you want to take a more theoretical or computational path. You like to study complex materials like large proteins, or this is a snapshot of the membrane of the cell. Or you want to simulate, to learn how to simulate quantum electronic devices like transistors in our electronic devices, or likely the next generation of transistors. Then you have to learn about quantum physics of matter, nanoscience, because everything at this level is nanoscience, or nanomechanics, which is exactly how materials interact when they move with respect to each other. This likely involves to learn how to take advantage of the most advanced hardware architecture, computers, because performing such simulation is really a demanding task, and you need the most powerful computers in the world, and you learn how to use them. And you really, as a master student, you really use them in a computer center which is near to Modena. If you like more experimental activity, you may want to take an experimental curriculum in nano and biophysics. Then you have 2 compulsory laboratories. That's why they are green, and they are red because they are compulsory. So that means nanofabrication, so how you manipulate matter at the nanoscale, that is 1 billion of a meter on this scale, to change the properties of the material itself. Then there are some basic courses like advanced statistical mechanics, quantum physics of matter, and so on. And then again, other computational laboratories which are necessary also for experimentalists. For example, how with the computer you should manipulate your signals for image processing. Okay, these were just okay, and then you want to specialize either in nanoscience or nanotechnology, which means, for example, exactly manipulating and changing the properties of the matter at the nanoscale. Then you probably want to follow courses like magnetism and spintronics, quantum information processing, and so on. Or you may take a more biologically oriented study plan. If you like more biological system, you may want to study how proteins works or cells works on a physical ground. Then you will learn probably about Monte Carlo methods, which are a way to simulate also biomatter, chemical physics of biomolecules, and especially biological physics. and medical physics, which is the applied sector of biophysics, which opens you also the possibility to work as a medical physicist in a hospital, for example. The applied physics curriculum is somehow different from the other two, in the sense that the other two have a strong basic content. They are probably more suitable to students willing to proceed with a PhD. And the applied physics curriculum is probably more suited to a student who already foresee a career in a company, or in a hospital, or in a large organization, or in teaching. Because this curriculum doesn't have compulsory courses and is more flexible or less constrained in the choice of the courses. Exactly because we believe that students who want to take a career in a company don't really know exactly what they are going to do. The best thing is to provide them with a large spectrum of high quality but broad spectrum competencies. And in this, in some of the courses you find, of course, for example, you may want to learn about machine learning and deep learning, which is a technology, which is a numerical technology, which is now pervading most of applications, whatever you do. Medical physics, being a physicist in a hospital is quite challenging career, and nowadays it's also including a lot of machine learning implementation. High performance computing for science means learning the most advanced numerical techniques, and for example, a course in physics education is needed if you want to become a high school teacher. Then, choosing the other exams, you may want to become particularly expert either in numerical methods in general, or technologies, or teaching, depending what you want to do. But in general, you want to have a broad spectrum of competencies. So this is, for example, using top performing computing, or using deep learning techniques to simulate complex systems, diagnostic images as a medical physicist, or high school teachers here. Okay, so what's special about this course? Of course, it's an entirely English taught master. That's why we are here. Erasmus project includes several sites, both in several places of Europe, so Grenoble, Montpellier, Nijmegen, Vilnius, Salamanca, and Warsaw. We have a program of visiting professors, that is, professors which come from other universities from all over the world. In the last year, we had professors from the University of Princeton, Graz, Japan, from South California this year, who teach a course, their own course, and they are really from the world expert in each areas, and we take advantage of this with one course which is devoted to them every year. And we have a program of excellence. That's a program for the most motivated students who may want to anticipate some of the activity from the graduate school. So some of the didactic activity is anticipated to the master course. That's only for the best students, of course. But the advantage is that if they want to enroll in the graduate school later on, they are freed already from some of the didactic activity which has been anticipated to the master. So they have more time for the research activity. How you enter our master? The internship and defense first. So internship is really the main point about a master. Internship is where you really take what you have studied and put it in practice, and also develop all those skills, and learn how the system works. That's where you pass from being a student to become a professional. Okay, So that's very important part. When you take the internship, okay, you can enter the internship whenever you like, basically. You just go to some professor you like and say, well, is there anything interesting for me to do? The duration is between 6 and 9 months, but on average, but it's not fixed. And you can enter any research group in the department, but we also have projects which involve other organizations or other university centers which we collaborate with. Okay, for example, we have the university hospital next to the department. So there are every year we have a few students taking an internship in the hospital as a medical physicist. And of course, we have a presentation of all the available projects every year. Okay. Then you do your research project. You write up your thesis, and you prepare an oral presentation in front of a committee, which is about 20 minutes, and then there are questions and so on. There is a committee which may include external experts when this is needed, and it's a public discussion. So you can also invite, there are the professors, of course, but you can also invite your friends and parents when grandma and grandpa often like this kind of celebration. That's the Italian style. How do you enroll in Modena? So the prerequisite is that you have a bachelor in physics or some related areas. Can be chemistry, can be some type of engineering. The important point is that you have studied some classical and quantum mechanics, electromagnetism, and you have some introduction. You had some introduction in structure of matter, molecular physics, and solid, and so on, and some statistical mechanics. And of course, the usual background of physicists or engineers in mathematics, mathematical methods of physics. You should have some background in laboratory, practical laboratory of classical physics, and some practice in coding and numerical methods applied to physics or general. Okay. Then you can ask to be enrolled. And how it works, there is a call issued every year. This is in common also between all the masters in Modena. There is a call every year, normally in February. If you write to me, I will put you in my mailing list. As soon as the call is issued, I will send it to you by email. Or, of course, you can find it on our website. Then the student registers on the website and asks for an evaluation of the curriculum. Okay. Then, as soon as we receive this request, we get in contact with the student. I don't know what's happening now. No. Well. Okay. Ah, I'm sorry. Can you switch with the technician? Maybe. Ah, no, okay. Here it is. Great. So when we receive your request, we get in contact with you and we arrange for a Skype call so that we can really see you and we can discuss which are your interests and so on. And we evaluate your CV and your motivations. After that, you receive an acceptance letter by email, and you bring this letter to the embassy, who will give you the visa if you need it to enter Italy as a student. Everything works online, so it's not needed to send me any CV. Everything has to be done online with a control procedure. And when we receive your request, you will get the acceptance with an average time of 2 or 3 weeks, so quite rapidly. Why you should enroll in Modena? Well, because we have a very high student-to-staff ratio. So basically, every teacher on average has 5 to 10 students in the classroom. So there is a daily interaction, and you can always knock to the door of the teacher. And I mean, the life is very easy from this point of view. You can get the most of it. It's a very flexible program. That is, we have few compulsory courses, and we allow large personalization of the study plans, although we control that. I spend a lot of time in giving advices to students. We are an internationally connected research center. And there is, for example, a daily activity of seminars. We have scientists coming up and down, and you can always find seminars of your interest in our department. And last but not least, is you live in a lively, historically small city where it's quite easy to live in, with a campus with most facilities there, and also there is for foreign students. It's important to know that there is an international airport which is only 30 kilometers away, and you have a shuttle leaving from the campus and dropping you exactly at the airport. So it takes 40 minutes basically. So it's very convenient if you come from abroad. Okay. That's where you can find more information. This is our website, department website, and then you can follow in the menu to the didactical part or research part, if you like, if you're interested in, and find informations among other things on our master degree, and also some opinion of our former students. Okay. Basically here you can find the information I gave you today and also additional informations. Okay? Great. So now you have a bachelor in physics, you have a master in physics, and you want to proceed for a PhD. Possibly because you are motivated for an academic career, but it's more and more important also if you want a career in a company. In Modena, we run a graduate school for physics and nanoscience. And as the name suggests, basically we have two paths. One, which we call physics, basically aims at giving you a very solid background in physics, either on the experimental side or the theoretical side. But I should say that one of the traditional approaches in our department of the physicists in our department is really to be a connected community between experimental physics and theoretical physics, not necessarily inside the department. But I myself, for example, as a theoretician, the things I like most is to interact with experimentalists and work together to learn new things. So the idea is that with this path we have a PhD students which are really experts in their own field, and presumably, they want to proceed for an academic career. The path in nanoscience, nanotechnology is a little bit broader in scope, in the sense that it enrolls not only physics but also students with a degree in different disciplines, normally in chemistry, biology, and engineering, because nanoscience, nanotechnology is a field which really needs to merge different expertise from different traditional, so to speak, fields. Okay, so in our laboratory, really work as a researcher, not as a PhD students anymore. Work people with a background in biology, engineering, and chemistry, and so on, and they work all together. The idea from the PhD point of view is to train professionals which are really able to talk to other professionals in different areas. When you have a strong background, talk to experts in different fields is not always simple. You really need to learn, basically, and broaden your expertise to be able to interact in a productive way with experts in different disciplines. These are two paths in the sense that we enroll students with a background in physics or different kind of backgrounds, but in the end, the research projects are, of course, of similar kinds. So these two happy guys are two of our PhD students. So you see how nice is life in Modena. The graduate school itself is a 3-year program, as most programs in Italy. We allow 6 more months if your project needs some more time to be fully developed. We have an interdisciplinary committee of scientists which runs the PhD program of 20 members. Interdisciplinary means that they are not all physicists. We are about 15 physicists, and 25% is from different disciplines, chemistry and engineering. Students in our graduate school have some small teaching duties. Basically, they don't have to teach. Only we ask them to help us, for example, in the lab, or in the laboratories, or in practical activities, or developing exercise, the blackboard, but for no more than 20 hours per year. So we have a rule which is equal for everybody. So this is really small, and it's actually more at their advantage, because being in the classroom is very instructive. On the other hand, we ask them to attend an extended activity in courses and seminars. So we offer, and we try to increase our offer of graduate school courses, which are topical courses of, say, 5-6 lectures typically. And we ask each student to follow a number of them. And there is an annual audit by the committee of each student. So we don't leave the student alone with the supervisor. We don't want them to get lost in some hyper-sophisticated thing which maybe doesn't bring anywhere. We would like to have the students who are in the end of the program feel satisfied of some a result. The project itself can be taken in one of our labs. We have a lab in low temperature physics, in quantum electron microscopy. We have facilities for nanofabrication. We have Superman is a lab on surface physics. Sesamo is another nice name for a laboratory in electronic and optical spectroscopy of surfaces, and the nanobiology, nanobio laboratory. I should say that most of the activities are actually not listed there because they are theoretical activities, computational activities which are either merged inside of the laboratories, in the sense that are theoreticians collaborating with these laboratory activities, or theoretical groups themselves. And while the experimental colleagues work in the lab, but they also often access to large-scale facilities. For example, synchrotron radiation facilities. We have one quite high-quality Electra in Italy, but can be in Grenoble, can be UK. Or they access a Fermi facility, which is a free electron laser, which is now a very an increasingly important facility, or at the ESRF in Grenoble. Theoretical students who take a PhD project in computational physics, however, normally access CINECA, which CINECA is a high-performance computing center, which is in Bologna, so 30 kilometers away. And it's one of the tier 0 HP centers in Europe. It means that, among other things, that Cineca installs every 3 years one of the 10 most powerful machines in the world. Okay? And they also have a training activity which is standardized and is world level training activity in all new techniques of HPC. For those who know what this means, this could be Python, can be other programming languages, or techniques, profiling, optimization, and so on. So that's very, very important, because when you take a computational project in Modena, you really take advantage, one of the best places in Europe for computational condensed matter physics. Okay, just a flash of topics. There is a website, of course, still from the same website. You can follow and find the graduate school, and you can look at the topics. And I just flash you a few images. Well, what you can see here are mostly, you can get here as mostly keywords that you can see they repeat again and again. So you have an idea what's the activity mostly about. So nanostructures, for example, molecular dynamics is a basic simulation technique. This is electron microscopy, but taking it at a different level by really working with the electrons to investigate their quantum properties. Again, nanoparticles, catalytic properties, that is how a surface of a material catalyzes chemical reactions. Lubrication, so how two surfaces slit, one with respect to the other with water in the middle. How it really happens at the molecular level. This is a simulation activity, of course. Single molecule studies. I was telling you about how proteins fold or misfold, and how you can pick them from the two sides and elongate the protein, and so on. Okay, so these are different topics which have been covered in the PhD project recently. How you enroll in the PhD, you need a Master of Science in Physics, and I mentioned also in other disciplines. Of course, you need a strong interest and motivation. So PhD is not for all students. You really need to be a very brilliant person, and very particularly should be very motivated. Okay. The procedure call is issued in August for all university in Italy, I guess. And the selection is, everything is remote. So you send the curriculum, you send a motivation letter where you explain why you want to get to study in Modena and what you would like to study. What's your scientific interest? And you send 2 recommendation letters, for example, from your supervisor of the master internship or any other scientific personality who knows how you work. And it's recommended that you, before sending an application for a PhD, it is recommended that you visit our website, see which are our scientific activities, look at recent publications, for example, pick up the name of some scientist you would like to work with and get in contact with him or her, okay? So that you can write a motivation letter which is, well conceived. Okay, that's it, I think. No, yeah, that's it. I leave you with some, no, it's not running. Okay, it should be running the pictures, but it's not. Anyway, these are pictures taken from our department. I don't know if there are questions now or later. They're welcome.
I would like to ask available just to look through.
The program of what?
Program of I'm interested in doctoral program in physics and
Yeah.
nanoscience.
Okay. So the lady asks whether programs of the graduate school are available. Yes, of course they are. So this is the again the address of the department. That's how it works. Sorry, this is the address of the department, and this is my name. If you need information, of course you can send questions to me. But sorry, I'm going the wrong direction.
You see, I'm asking because not every university just shows their programs on websites, you know.
Yes, no, we have. Okay, so this is from the website I showed before. You look for the Graduate School of Physics and Nanoscience, and here you have a list of the topics which have, the highlights, so the best project we had so far. Here there is a program where you can find the list of the courses which are available for that year. We don't really have a credit system at the PhD level in Italy. So this is more an internal rule, okay? Here you have a list of courses, the students which are made available to students. But if a student has a specific lack of background, if we believe that a student has it would be nice that the student has some course or introduction to a specific topic which is not in our program. We just look for it somewhere. Maybe the student will go to a different city for a week to follow a course. We really want the students to be well trained on what is needed. We have a program of courses, but it's not fixed every year, and there is no necessarily correspondence in credits, because the PhD program doesn't work like that in Italy. Okay.
One more question. If you have any programs, bachelor, master's, or doctoral programs in material science?
Yes. Okay. So the master in physics is in I go to the beginning. To the research activity. Well, let's do like this. The master in physics is 60–70% a course in material science. That is, of course, if you want to study quantum gravity, it's fine, you can study quantum gravity. But most of our research activity is more in nanoscience, which is between basic condensed matter physics and material science. Okay, most of the publications are in chemistry or chemical physics reviews. So we are really in between basic condensed matter physics and material science. If you want to take a thesis in material science, this is really a place where you can do it. There are other programs in Modena, however, which are in material science. There is a course in engineering which is oriented to material science. And of course, you can take a master in chemistry, which can also be taken as a path most toward material science rather than molecular physics, for example, chemistry. Okay?